Now, for the test of a series and parallel pump flow, lecture for Mechanical Engineering Laboratory 2. So, ito yung sa picture, makikita mo yung equipment ng pag-test ng series parallel pump. Andito yung mga sensors, flow sensors, yung flow rate, then mga pressure, kasi kailangan mo yon. Then electric bulb yan, flow sensor again, yung total yan, di ba nag-mix na. So, power supply ito, yan. So, pumps operating in series, ito yung principle niya. Kasi hindi lang measurement ang ano mo. Sa measurement, magko-compute ka para makuha mo yung horsepower. Di ba? To connect two pumps in series means that the discharge for the first pump, this one, so yun yung pump, is piped to the inlet of the second pump. Unahin natin yung series. In this type of arrangement, all the flow successively passes from one pump to the next with each pump, adding more energy to water. This is a typical arrangement in multi-stage turbine or submersible pump, where the same discharge passes to all stages in its built additional head. Yung flow rate the same, yung head ang nagdadagdag. Often, series configuration are used when head requirements of the system exceed that which can be supplied by individual pump. So, magdadagdag ka. Yung head required ng isang pump kulang, so magdadagdag ka. They are also used in system with variable head requirements. A typical example is a small centrifugal pump used as a booster, or for that matter, any booster pump in any water system work in addition to the main water pump. Figure 2 shows head discharge curve for the two pumps operating in series. Yung pump A, pump B, combined. So, i-add mo yung head niya. Ito, plus head of B. So, total niya, yan. Or, yung pump B, i-add mo na lang itong distance na yan dito sa taas. So, this is now the combined curve for pumps A and B operating in series. So, figure 3 presents a parallel configuration of two pumps. Next is parallel na. Okay? So, pump A, then pump B, same siya, common source niya. Then, common outlet. So, figure 3. So, a typical example of this arrangement is a situation where two or more pumps draw water from a single source and all the flow are discharged into a single pump. Another example is a situation where small wells are providing the required discharge. Parallel arrangement are also common method of meeting variable discharge requirement of the system. So, figure 4 is the head discharge characteristic for two pumps operating in parallel. So, yan. So, pump A, pump B. So, add mo yung flow rate. So, mag-total yung flow rate niya. So, ito yung flow rate ng B. Andito. Head and Q. Di ko na-explain yung alternate of abscissa. Ito yung capacity dito. Tapos yung capacity nyo, i-add mo doon. So, magiging dito na. So, this is now the combined curve for pumps A and B operating in parallel. So, review yung fluid machinery nyo or fluid mechanics, fluid machinery. Now, efficiency consideration. During the pump selection process, only pumps having high efficiency above 70% for the discharge system should be considered. Okay? Above 70. Yung sa mga centrifugal, mga ano, centrifugal pump, common sa mga chilled water system, at least mga 70 above. So, yung iba, yung mga multi-staging, so that's mga 65, 70 pababa, ano pa yon. So, example. So, the 32-inch pump in the figure shown is used at 1170 RPM or revolution per minute in a system whose head curve is SS in feet is 100 plus 1.5 Q squared with Q in thousands of gallons of water per minute. Find the discharge and brake horsepower required for one pump, B, two pumps in parallel, and C, two pumps in series. Which configuration is best? Okay, so itong example, nga, sa balikan nyo na lang yung fluid machinery. Nandun yung theory nito. So given yung figure, system whose head is SS feet is 100 plus 1.5 Q is squared with Q in thousands of gallons of water per minute. And see more example ng problem solving nitong mga pump curve. So ito yung pump curve, head system curve, hindi pinakita na. Okay. Ang system curve, mula dito papunta doon. Ayan. Yan yung pump curve. So, required, the discharge and brake horsepower required for A, one pump, B, two pumps in parallel, and C, two pumps in series with configuration is as best. So, diyan napapakita dito. So, solution, determine approximate equation for 32-inch pump curve. Ito. 32 inch tayo, di ba? Yan. Ito yung pump curve. 32-inch pump. So, dito natin testingin yung calculation. So, consider a parabola y minus x is equal to ax squared. So, this is consider na parabola. S minus a is equal to bq squared. Kukunin natin yung curve niyan. From the figure, when h is 490, q is 0. Ito, 0 ang q mo. So, head mo is 490. Di siya umabot baka gawin yung 500. When H is 450, Q is 12. Sa Q is 12, binabaliktad ko lang kasi HQ ang butter niyan eh. So, 12,000 GPM, di ba? 1,000 yan eh. So, 12 is 450. So, exactly siya. So, solve for A and B. 490 minus A is equal to B times 0 squared. So, A is 490. Then, 450 minus 490 is equal to B times 12 squared. So, B is negative 0.277. Therefore, the pump curve is H is equal to 490 minus 0.2777 Q squared. So, yan. Yung isang pump, yan ang curve niya. So, now for one pump, solve for Q. So S is equal to 100 plus 1.5 Q squared is equal to 490 minus 0.2777 Q squared. So Q is equal to 14.812 times 1,000. GPM is 14,812. So this is now your answer. So sinulve ko yung Q, nakuha ko is 14.812. Since Q is in 1,000, so multiply ko na ng 1,000 direct. Okay. So, kasi example lang to. For curve NP is 0.81. From the curve, 14.812 divide mo na 14.8. This is 14, 15. So, andito siya. So, ang efficiency niya is mga yan. So, interpolate mo sa dyan. Graphical sa mga 0.81. Diba? So, check nyo. Machi-check naman niya. I-roller nyo lang yan. Tapos, interpolate. Then, H is equal to 490 minus 0.277 times 14.812 squared is equal to 0.42 or 429. Okay? So, BSP is equal to QH over 3960 NP. So, formula to sa power, sa pump. Where Q is in GPM, H and feet. So, BSP is equal to 14,812 times 429 over 3960 over 0.81 is 19,1981 horsepower. So, answer. Ito yung required mong horsepower. Okay? So, wait lang. So, yan. Inayos ko lang yung exponent. Tapos to. So, for two pumps and parallel, so head is constant. So, Q1 is equal to Q2 is Q over 2. Nahati. So, equal yung pump, same pump. So, solve for Q. So, pag nag-same ko, same brand, same model. Yan. Diba? Kasi same nga yung pump mo, same capacity, same head, pero magkaiba yung brand. So, magkaiba ng model nun. So, mag-ibang performance curve nun. Iba ng performance curve. Okay? Yung iba dadayain, parehas magharap ng performance curve. Hindi, iba sa ibang brand naman pala. Okay? So, for Q, the head is equals to 100 plus 1.5 Q squared is equal to 490 minus 0.2777 times Q over 2 squared. Ito yung system. Ito yung pump, yung head ng pump. Okay? Bakit hindi divide-divide to? Sa system to eh. I-equate mo lang yung head ng pump. So baka i-divide mo rin yan. So Q is equal to 15.764 times 1,000 GPM is 15,764 GPM. Ito yung answer mo. So Q1 is equal to Q2 is equal to Q over 2 is 15,764 over 22 is 77,7882 GPM. From the curve, 0.58. This is 15.76. So this is now, ang Q mo is 7882. Hindi 15. So 7882 andito. So bababa siya, di ba? So 0.58. So head is 490 minus 0.277 plus 15.764 over 2 squared is equal to 472.75 feet. Kasi yung model ng pump mo, same. So, pero kung mag-select ang efficiency na 70, mag-other model ka, so mag-iiba yung performance curve niya. So, BSP1 is equal to Q1 over 3960 NP. So, ito na pala yung 472.75 yung head. BSP1 is 7882 times 472.75 over 3960 over 0.58 is 1622 horsepower. So total is 2 times 1622 horsepower is 3244 horsepower. So malaki. So B, two pumps in series. Q is equal to, is constant. Solve for Q. S is equal to 1.5 plus 100 plus 1.5. Ano yung Q doon is equal to 2 times 490 minus 0.277 Q squared. That total yung head mo, di ba? Ang Q mo ito. So Q is equal to 20.692 times 1,000. So Q is 20,690 GPM. Then from the pump curve, this is 0.86. So H1 is equal to H2 is 490 kasi same pump siya. 490 minus 0.2777 times 20,690 squared is 371.1 feet. So BSP1 is Q1 times H over 3960 NP. So BSP1 is 20,692 times 371.1 over 396 over 0.86 is equal to 2255 horsepower. So the total horsepower is 2 times 2255 is equal to 4510 horsepower. So best configuration is for one pump only with lowest brake horsepower. Di ba? Kasi gusto mo nga maghati, mag-spare. So mag-reduce ka ng pump para bumaba rin yung horsepower mo. Ito kasi same pump lang. Okay? This is the end of this topic. Ito yung mga pang-test ng pump.